Okay, so for my first video for the 205L, I'm going to finish up the section 4.1 that we started when we left class. Um, in sections 4.1, 4.2, and 4.3 of the 5A, making sign charts is going to be very important. And so we're going to go over this. Now, again, your best approach to this is to try and do the problems on your own. Make the sign charts on your own and then play the video and make sure that our answers match and make sure that our work is similar, that you know what you're doing and how to do this on your own. Okay, so let's go through these problems. I don't remember where we left off, but I know that we started this worksheet, and I'm just going to start here. All right, so make a sign chart for the expression negative 4x squared minus 19x plus 5. Very difficult to see this and know for what values of x the output will be positive and for what values of x the output will be negative. But if we factor it, then the work is not so bad. Okay. So the first step to factoring is to factor out the greatest common factor. But for 19 and 5, um, the only number that divides them is 1. So we don't have a common factor. But I prefer to factor when my leading coefficient is positive. So what I could always do is factor out a negative 1. Factor out a negative 1. And that will leave behind 4x squared plus 19x minus 5. Okay. And so this is going to be very useful, especially for one of the things that we're going to do in the later section. You should always check your work, right? So when you're factoring, um, what you're doing is reverse distributing, right? And so if we distribute this minus 1, the minus 1 times the 4x squared will give us minus 4x squared. The minus 1 times the 19 times the plus 19x will give us the minus 19x. And the minus 1 times the 5 times the minus 5 will give us the plus 5, right? And so that's another way of figuring out what goes inside the parentheses, is to ask yourself, when I back distribute like this, what needs to go here to end up with a minus 4x squared? What needs to go here to end up with a minus 19x? And what needs to go here to end up with a plus 5x? And so when things get a little bit more complicated and you know what you want to factor out, that's how you can figure that out, by asking yourself, what needs to go here, here, and here. Okay, so now we're ready to factor. So it's a trinomial. It's probably the product of two binomials. Don't forget this minus 1 here. Now notice that there are a couple ways to multiply together to make 4. But there's only one way to multiply together to make 5, 1 and 5. And because this is a minus right here, that tells us that 1 has to be plus and 1 has to be minus. Now where they go, we'll figure that out at the end. But for right now, we'll go with the 5x plus 5x and minus x. Okay, I'm sorry, no x's. Those are the constants. Okay. And so there's only a couple ways to multiply together to make 4, right? And that would be 1 times 4 and 2 times 2. Well, the nice thing about having 2x and 2x is it doesn't matter where they go. But if we do that, then we get 2x. Sorry. From these two, we get 10x. And from these two, we get minus 2x. And then we end up with 8x, which is not what we wanted. So, can't be that. And then we know it's got to be 1x and 4x, right? Doesn't take very long very difficult to just look at it and know how things go. So it's got to be 1 and 4. But rather than just running through them, right, you should make an educated guess. Right? You want to end up all the way with 19, so you want to end up big. So that means that you probably want the 4x over here to get multiplied times the 5, and then the 1x over here to make the 4x squared. And then these two would make 20x squared. And these two would make minus x. And when we add them, we get minus 19x. Okay. Now, just by inspecting, you can figure out what makes each factor 0. And so then now by writing the polynomial in this form, you can now make the sign chart. This is, okay, so the numbers that go on here are the numbers that make this 0, and you could tell that what's going to make this one 0 is -5. Now, if you can't tell by inspection, if you have a difficult time with that, no big deal. It doesn't take very long. You're just trying to figure out what's going to make each factor 0. So you can just set each factor equal to 0, and then you will get 4x equals 1, x equals 1/4. These two numbers are the only numbers that make this expression 0. You should know that this is a continuous function, a continuous expression. It's just a polynomial. And so then, since these are the only numbers that make it 0, over here in this interval, it's either going to always be positive or always be negative. So to the left of -5, it's going to either always, so over here, it will always be positive or always be negative. Likewise, in between -5 and 1/4, it has to always be positive or always be negative. Because it's a continuous function, as we went over earlier, if somewhere over here it was positive and then somewhere over here it was negative, then somewhere in the middle it would have to be 0. But we've already figured out that the only zeros are at -5 and 1/4. So then in this interval, it either has to always be positive or always be negative. Same thing with this last interval over here. So to figure out whether it's positive or negative, you can make a table and you can pick a point in every interval, or you could look at your factors. To the left of -5, something like -6, when you put in a -6 in here, you will get a negative number out of this factor. Let me go ahead and erase this. For this one here, -6. 4 times -6 is -24. Minus 1 is -25. So that's also negative. So that's going to happen for every number to the left of -5 and for every number to the left in here and in here. So you will get a negative times a negative, which will then make a positive. Now, once you get past -5, -4, -3, 0, all of these numbers right here, when you add 5 to them, you will now get a positive number. These will stay negative because this is a line that doesn't cross until 1/4. So everywhere to the left of 1/4, this is going to be a negative. But now in this interval, you have a positive number times a negative number, and you will get a negative number until you get past 1/4. And then once you get past 1/4, this one switches. And once that one switches, then they are both positive. Ooh, but I made a mistake. We have this negative over here. So this is all wrong. To the left of -5, these two do make a positive, but then you have that negative. So you end up with a negative. In between -5 and 1/4, you end up with these two do make a negative, but then you have this negative over here, so you end up with a positive. And then to the right of 1/4, these two do make a positive, but then you have that one, so you have a negative. So make a sign chart. And in the calculus, we've gone over what the negative output tells you for the derivative and what the negative output tells you for the second derivative about the original function. But in this class, we're just going over the algebra. Okay, so if this was going to factor, And then it would have to be with an x and an x and a minus and a minus. And there's only one way to multiply together to make 1, but those add together to make minus 2. So this does not factor. And so then we can't do this by factoring. So again, this expression is continuous. It's all one piece. So we have to figure out what makes this expression 0. So to figure out what makes this expression 0, we can just set it equal to 0. And then we could either use the quadratic formula, or because this is just a single x squared and this is an even number, solving by completing the square is actually not going to be too bad. So I'll practice that just to show you how that goes. So we want a perfect square trinomial on the left. This one here is not helping, so we just get rid of it, subtract 1 from both sides. To complete the square now, we always take this number, divide by 2. So 4 divided by 2 is 2, and then square it. 2 squared is 4. So we add 4 to both sides, and this is now a perfect square trinomial. So then we factor this. This is x minus 2 squared. And then over here we have 3. Then we can square root. When you solve with the square root, do not forget that there is always a plus or minus. So this is plus or minus the square root of 3. And so then your zeros, the numbers that make your expression 0, are 2 plus or minus the square root of 3. Okay, and so now we can make our number line. And all that needs to be on there, the numbers that make this whole thing 0, which is 2 minus the square root of 3 and 2 plus the square root of 3. Okay. So right in the middle of these two numbers is 2. And so you can do a couple things for this. One of the things you can do is you can make a table. The square root of 3, 1 squared is 1, 2 squared is 4. It's somewhere in between 1 and 2, right? So 2 minus something in between 1 and 2, that's still going to be positive. So we could put in 0. And if we put in 0, we get 1. Right in the middle of 2 minus the square root of 3 and 2 plus the square root of 3, we could find by adding these two numbers and dividing by 2. And so that would be 2. And when you put in 2, you get 4 minus 4 is 0. So 4 minus 8, which is negative 4, plus 1 is negative 3. And then again, you could put in 4. And then you will get 16 minus 16, which is again 1. And so this tells you that to the left of 2 minus the square root of 3, since this is a positive number, you will always get a positive number. In between, since this is a negative number, you will always get a negative number. And past 2 plus the square root of 3, you get a positive 1, so you will always get a positive number. Another way to do this is to take out your graphing calculator and look at the graph. And when you look at the graph, you'll see that your vertex is over here at 2, negative 3. These crossings right here happen at 2 minus the square root of 3 and 2 plus the square root of 3. To the left of 2 minus the square root of 3, your output's above the x-axis, so you were positive. In between these two, your output is below the x-axis, so your output is a negative number. And past 2 plus the square root of 3, you're again above the x-axis, so you have a positive number. Okay, so let's move on to the next one. Probably didn't see anything like this in pre-calc. Maybe you did, maybe you didn't. But again, don't panic. Make a sign chart for the expression. What you need to do is factor. When you have your expression written in factored form, it's easier to tell whether your whole expression will be positive or negative. How do we factor this? Well, they both have an e to the x. We always begin by factoring out the greatest common factor. And they also both have a factor of 3. So we can factor out a 3 e to the x. That leaves behind 1 minus x squared. Now I told you that I do like to have my leading coefficient positive, but in this case I'm just going to go ahead and write 3 e to the x. I could factor out the minus 1, but this is a difference of squares, so it's easy enough to just use the difference of squares. 1 plus x, 1 minus x. Now what you should know about e to the x is you should know that the graph of e to the x looks like this. This is what you learned in pre-calculus. And what that tells you is that your output for e to the x is never 0. And so then this expression right here is always positive. So then the sign chart is solely determined by looking at the other two factors, the 1 plus x and the 1 minus x. For the 1 plus x, the 0 is at negative 1. For the 1 minus x, the 0 is at 1. If you take any number to the left of negative 1, negative 2, negative 3, you substitute it into here, you will get a negative. But when you substitute it into here, you will get a positive. And so a negative times a positive will give you a negative. Once you get past negative 1, this one switches. And then when that one switches, you will now have a positive times a positive, so you will get a positive. Until you get past 1, and then this one becomes a negative. And so now you have a positive times a negative, and you will get a negative. And so there's the sign chart. Make a sign chart for the expression over the interval from negative pi to pi. So we have the expression 2 cosine of x minus 1. So again, we're only looking at this on the interval from negative pi to pi. But what we need to do is we need to figure out what are the zeros of this expression in that interval. Can't do that just by looking at it, so let me go ahead and just set it equal to 0. 2 cosine of x minus 1 equals 0. So the 2 cosine of x will equal 1, so then the cosine of x will equal 1/2. Okay, you can't be comfortable with just the interval from 0 to 2 pi or just in the first quadrant. You have to be comfortable with whatever interval I give you. And so we're looking at this in the interval from negative pi over pi, negative pi to pi. Okay, so cosine of x is 1/2. So ASTC. If your angle falls in the first quadrant, all your trig functions are positive. So we're looking for an angle in there since we're looking for a cosine value of 1/2. If your angle falls in the second quadrant, only your sine is positive, so we can't have an angle in there. And if your angle falls in this quadrant, then your tangent is positive, so we're not looking there either. And if your angle falls in this quadrant, then your cosine is positive. So we're either looking in quadrants 1 or quadrants 4. Okay. 1/2, 30, 60, 90 triangles, what that should bring to mind. And so then this was 60 degrees. This was 30 degrees. And this was 1. This was 2. This is the square root of 3. So you want a cosine value of 1/2. You can see that we're dealing with the 60-degree angle. Right? The cosine of 60 degrees is adjacent over the hypotenuse. So that's pi over 3. And since we're only allowed to get there using angles between negative pi and pi, then we could start here and go straight up there, and that would be pi. We cannot continue going in the positive direction because then to try and get all the way to here, I would be going too far. I'm only allowed to rotate as much as pi. Okay. So then we don't go positive direction, we go negative direction. We go clockwise. And if we just go down, sorry, pi over 3. And if we just go down, pi over 3, and then we end up right there as well. So then now can go to my number line, put in my put in my zeros. We're only interested in this from negative pi to pi. And the only place that that's 0 on the interval from negative pi to pi is over here at negative pi over 3. And pi over 3. You can see then that if you put in pi, you will get negative 2 minus 1, which is negative 3. So then everywhere in this interval, it has to be negative. Otherwise, there would have to be a 0 in between there, and we've already said that there is not. Okay. In between negative pi over 3 and pi over 3, we can put in 0. The cosine of 0 is 1. 2 times 1 is 2. 2 minus 1 is 1. So then we get positive number here. At pi, we also get negative 1. So for the cosine, so when we put in pi in, we get 2 times negative 1, which is negative 2, minus 1, which is negative 3. And there we go. And so there's the sine chart.